In the next section, 5.2, we're dealing with polynomials, linear factors, and zeros. We know that for a polynomial, the linear factors tell us about solutions, which are zeros. So they're all the same thing. They're also identified as x-intercepts. You kind of see that down below here. That's jumping ahead of where we are. So what are we really going to do? We want to factor some things out. Okay, this does not have an equal 0. So as I look at it, it starts with a degree of 3, which is odd. So I'm going to look for the greatest common factor, which happens to only be x here. So I'm going to take that out, end up with x squared minus 2x minus 15. And since we're trying to get factored form, if that was all we could do, then we would be done. But I'm pretty sure there are factors of 15 that subtract to give me 2. That's x minus 5 and x plus 3. So as far as factored form, that's all we need to do. So these are the factors from x cubed minus 2x squared minus 15x. So if I can get those, what I find out is if it is a factor, then when I solve it, right, so I would get x equals 0 here, x equals 5, x equals negative 3. Those solutions are zeros. They are solutions or roots, and they are also x-intercepts. So as we take a closer look at these polynomials, being able to factor things out and making that connection back and forth is what we're after. So what are the zeros? So my zeros, remember that's where we're saying y is 0. So x equals negative 2, x equals positive 1, and x equals 3. How am I getting that? X plus 2 equals 0. X minus 1 equals 0, x minus 3 equals 0. Add 3 to get 3, add 1 to get 1, subtract 2 to get negative 2. We want to graph the function. Well, I know that it should be a positive cubic. So the only other thing I know is that the x-intercepts are negative 2, positive 1, and 3. Other than that, it should meet up with our regular function of down, up for the end behavior. Okay, so if we want to see exactly how tall those turning points are, all we really have to do is head right over to Desmos, plug it in here, and we start to see some of those values. So I have x-intercepts that go along from our factored form to get solutions. Okay, other than that, if we need to list our relative max and min, we can do that either through graphing calculator or through Desmos. Either way works. So we start to get a picture of what it looks like. Mostly looking for x-intercepts and also looking at the turning points. Does that look like? Well, you can see those relative maxes, max and min, are going to be a whole lot taller, but the intercepts themselves are 3, 0, and 5 of the negative variety. Next thing we have to do in this section is to do all that work in reverse. So we're saying, what is a cubic polynomial function in standard form with the zeros? So I want where x equals negative 2, 2, and 3. So how do we get that answer? It comes from x plus 2 times x minus 2 and x minus 3. Alright, so if we have zeros, that means x equals. The factors are going to be opposite. I'm going to look for opposites to FOIL together, because that'll give me x squared minus 2x plus 2x minus 4. That way I get to get rid of the terms in the middle. So now we need x squared minus 4 times x minus 3. So I get to FOIL again. Anytime there's opposites, that's a good thing. It shortens up the work. So we FOIL one more time, x cubed minus 3x squared minus 4x plus 12. We want to write it in standard form for the cubic function. So that'll do it. So the first thing we want to do is write up if we have zeros or solutions where x equals negative 2. How do we get that back over? So the first question we have is, what should we get for the factors that we're going to multiply. X plus 2, x minus 2, x minus 3, and x minus 5. So always working in opposites here. We had x plus 2 and x minus 2, so we know that's x squared minus 4. The outside and inside cancel. Since I'm going to FOIL, I might as well do the last two together as well. X squared, I'm going to get negative 5x and negative 3x, so negative 8x plus 15. Now there's no shortcut. We have to multiply. We're going to distribute x squared through the entire trinomial. So I get x to the 4th power minus 8x cubed plus 15x squared. And then distribute one more time. Negative 4 through the trinomial. So I'll start with negative 4x squared plus 32x minus 60. Add my like terms. So the quartic is x to the 4th minus 8x cubed plus 15x squared plus 32x minus 60. We can do y equals or f of x to write it as a function. So if we go back to the very beginning, finding the multiplicity of a zero, what are the zeros? That means solutions, that means x-intercepts, and multiplicity means how many of that solution. So as we look at x to the 4th minus 2x cubed minus 8x squared, first thing is the greatest common factor is x squared. So I get x squared minus 2x minus 8. What are the factors of 8? Let's subtract to give me 2. X minus 4 and x plus 2. So what are the zeros? That means I'm going to set it equal to 0. And I would get x squared equals 0. So I get x equals 0 and I get x equals 0. When I do x minus 4 equals 0, I get x equals 4 and x plus 2 equals 0. So x equals negative 2. So we have a multiplicity of 1 for x equals 4 and for negative 2, and a multiplicity of 2 for x equals 0. How does the graph behave at these zeros? So as we take a look at that, and we take a look at our zeros, notice at 0, 0, when we had a multiplicity of 2, the graph will intersect with it by touching it, but not actually going through it. At 4 and negative 2, we see it goes through as an x-intercept. So a multiplicity of 2 means that it will touch, but not go through. Multiplicity of 1, it goes through. Other items on the graph, we've already been using these words, relative max and a relative min. That means it doesn't have a true maximum value like a parabola. It just means that between some values, so between a left bound and a right bound, we can say this is the highest point it reaches. So same thing, left bound, right bound. That's how we deal with it on the graphing calculator. And we actually ask the calculator to calculate a max or a min based on which one that we want. These are located at turning points. Identifying the relative max and min, we will be using a graphing calculator or Desmos for all these. So if we have to deal with it, we know that it is a cubic with a positive. So all of our positive odd powers have an ending behavior of down and up. So the next thing we'll do is actually just plug that in so we can take a look at what the graph looks like. As you look at the graph, you can see exactly why we want to use our graphing technology instead of guessing some numbers on what's going to happen. We can get our x-intercepts, our y-intercepts. What we're asking for here is the relative max and min. So we have a relative max located at negative 4 paired with 80 and a relative min at 2 paired with negative 28. You can see from the x-intercepts that they are not super nice numbers. So that means that as we were trying to factor it, if we were going to do that, it does have a greatest common factor of x, and then after that we would not be able to use factoring as a method. We'd be using quadratic formula or complete the square if you want to get crazy with it. Alright guys, that pretty much wraps up what we're doing here. So the last thing you have to do is show me what things you picked up. So lesson check 1 to 6 is the remainder of the homework. Make sure you have some answers. You do have a full page to answer those. So we want to find the zeros. Remember that is x-intercepts. You want to write it in standard form. So if these are the zeros, change them to factors and then multiply it all together. And then 5 and 6.